Running this process, and it is patented. We've been running it since 2010. We processed everything from cotton stalks, wood from scrap wood from lumber mills, railroad ties, MSW, tires, plastics, HDPE, polypropylene, polyethylene, mixing all of those together. Each one produces power. Each one produces a gas that we can produce power out of, produces a BTU value that we can draw and get power out of. Reduce our carbon footprint of the garbage by 99%. So we're pretty comfortable with those numbers. This is a typical canister, 8 feet high, 5 feet diameter. It will hold anywhere from 500 pounds of garbage to 2 tons of garbage. Again, depends on how the MSW is processed, whether it's baled, compressed. We don't sort any materials. We just process it as is. It can take wood, glass, metal. We sort it after when it's clean. It's been hydraulically or thermally cleaned. Alright, the gentlemen are putting the cover back on. We're going to lift up the vessel, so I call it, and place it in the autoclave, which is standard autoclave. This is good for 600 degrees Fahrenheit at 450 psi. It's a lower temperature because most of all of the process is contained in that vessel. So once the vessel goes in, there's heat shields inside, and the way the air runs down, we actually bring the air down the sides. It acts as an insulator as well as a preheating of the air. It comes back up and goes through the vents that are in the top of those canisters. So we keep the average temperature of the autoclave doesn't go above 150 degrees Fahrenheit, and we're generally somewhere between 50 and 100 psi on pressure. Well within and expect at least 25 years out of our autoclaves. One of the keys to this is very few moving parts. The only actual moving part on the autoclave is the lid that opens and closes. So the other moving parts on this process would be the valve, the air coming in valve, the process valve going out, and then pumps that are pumping our scrubber water back and forth. So from a maintenance standpoint, very, very few moving parts. As a matter of fact, as few as I could make it and run the machine. So very straightforward process. Again, the process begins by updraft ignition process. We have a diesel fired burner that sends the fire up the bottom and ignites the bottom prop of the vessel. Once that has happened, usually takes about 5 minutes, the process is stopped and we begin a downdraft gasification. And the air actually goes in through the top, goes through the vessel, out the bottom of the vessel, into our scrubbers down here. We'll have downdraft gasification. The gas is going to come into our first scrubber. And it's a wet bed, packed bed scrubber. It's going to bring the temperature of the gas down. It's going to go through a second packed bed scrubber, a bag house, and then it goes out to our flare. Again, very simple system. And what we're doing here is breaking down the MSW into hydrocarbons. By keeping a low oxygen environment, we're preventing the formation of dioxides and preventing the formation of these cyclical carbons and stuff that everybody's trying to get rid of. We don't use a lot of water. We actually generate more water than we use, because all the water coming from the from the garbage or the municipal solid waste ends up in our first scrubber. So we'll have to decant off our first scrubber. Controls, we run Opto 22 controls. Awesome, best control system I've ever worked with. Very simple to operate. It runs off, rather than ladder logic, it runs off flow sheets. So the guys actually have a version of it on a website, so they can use that, and they walk around the building with tablets, and they can operate any valve, any temperature sensor. They can look at every piece of the equipment and know what's happening with it, turn it on, turn it off. So really really integrated, and every single sensor is cataloged. So the amount of information that you get to catalog is incredible. So you get to know exactly what's happening with your process at any minute, and we can send that to any computer anywhere in the world. Very simple, very simple. Flow meters, this valve, solenoids, all very easily to maintain, very easy to switch out, change, have spare parts. You can locate these parts just about anywhere in the world. Another key to what we did. These are some of the hydrocarbons that we went through. This is actually probably 2 loads of garbage that have been processed, and including tires. This is these are the steel belts from tires. This is what's left of the tires that we processed down. We mix it with the garbage. This is just paper. This stuff is, when compressed down, again, a good soil amendment. You can take the tin cans, the steel, it's all clean. You can, rather than sorting garbage before it goes in when it's nasty, I far more have people going through nice clean carbon. This is sterile, it's clean. If there's a needle, if there's hypodermic needles, they are sterile. They've been heated up past 500 degrees C. Nobody's going to get any noxious disease. We have been approached by a number of hospitals to talk about doing medical waste. It is actually a very good system for doing medical waste. So a lot of different opportunities to do with one system, from making an engineered carbon or carbon to running it to ash. The fact that we can do hydrocarbon material or carbon-based material and inert material at the same time provides some opportunity for us to be able to do landfill reclamation. Some of the construction debris that normally wouldn't be able to be touched because of there's drywall or there's some particulate in it that either an incineration or a gasifying system wouldn't work. We don't have that problem because we're running continuous batches. We can process just about any material there is, and we'll pull out the BTU value that's available in that material and leave behind what's not.